Welcome back, coders, and let's continue the series on Python. So today I don't need this class today, and today we're going to talk about another concept. Well, I think today's class is over. Yes, and today we're going to talk about another concept. So imagine you have heard about in history kings, right? So you've heard about the Mauryan dynasty, right? So it had great Chandragupta Maurya, King Bindusar, and Ashoka the Great. So the land that Chandragupta Maurya captured was of Bindusar, right? As Bindusar was Chandragupta Maurya's son. And then Bindusar himself also captured many lands, and that was of Ashoka the Great, right? And Ashoka the Great also captured many lands. The most famous was of Kaling. So you might be thinking, why I'm teaching you history? I'm talking about history, right? But today's concept is related to that. See, Bindusar inherited something from Chandragupta Maurya, and Ashoka the Great inherited from Bindusar. So this is known as inheritance, and this is what we're going to talk about. So let me define. We need class today. As for inheritance, we need that class. I can say king, or I can say emperor. No. Like this. Then I can write over here lands. I can say def land 1, okay. Then print land 1, and he also have captured land 2. So here you'd have print land 2, okay. But we need over here the most important this, okay. So this is our first class, and now if we do a second class here, class I've copy pasted it, and I'm changing now land 3 land 4, okay. So he has captured land 1 land 2 like this, and I know emperor is greater than king, so I can say emperor as the grandfather, king as the father, okay. So then king is inheriting something from grandfather, right? So I will write here emperor, and that's the method of inheritance. So I can also write here k is equal to king. I have an object over here king, okay. Then I can say over here k dot land 1, okay. Now let me just open my console, and now let's run the code. Oh, land 1, it worked, because now the king has the land 1. But if I say define an object like I could say emperor, but it would not be, it would not have land 3 and 4. Oh, I by mistake forgot to write over here. Same. So there are types of inheritance also. First is single inheritance, then is multi-inheritance, and then is multiple inheritance. Okay, so here this is single inheritance, and if I write prince also, who can be the future king, and he will be, unless some other king captures the land, but the main is this, why not the prince king. I can also copy paste it like this, and then like this. Then he has land 5, land 6, okay, then land 6, land 5, okay. So for inheritance I will say king as, oh my mistakes, spelling error, as the king have everything of the emperor and he has something of himself also. So the prince have everything of the emperor, everything of the king, and something of himself also. So now if I define an object named P is equal to prince. See, you can't understand this object this topic if you will not relate to prince and property. Oh, there's notifications, I get many notifications, but the PC should know that I am making a video, land 3 self, and the brackets are the most important. Knowledge on the code, and see he has land 3. This is multi-inheritance. And now let's talk about multiple inheritance. If I say that king doesn't have anything of the emperor, the king is useless. I'm not talking about Bindusar right here. The king is useless. A bad king, you can say a bad king. The emperor is not giving something to him, so he is giving to the prince. So here we use multiple inheritance. Emperor. See, there's a break over here, and emperor has given over here like this. So will it work? I will try with land 1 over here. Let's check if it works. Yes, it works, as I have king, emperor over here. So this is the concept of inheritance. I'm just talking about this prince 1, and I can tell you that this class is super class, and this is subclass, and this is also subclass. So subclass and inherits everything from superclass. If something were not mentioned, then it can only some things inherit, but superclass can't inherit something from subclass. I gave you a beautiful example of kings. So for the time being, let me remove this all. Suppose I don't have it. Okay, so here I'm calling, I can say E is equal to emperor. Yes, so it's an object. Then let me just run the code and check what has happened. Oh, why? I don't have print function here, that's why only. But here you can see that I told you that it's calling init by itself, by default. But let me just define my init method. In this concept we'll call only methods, not functions over here. Then I can say print, I can say emperor here. So let me run the code. As you can see, as I told you that it's calling init by itself, and it worked, emperor. But here the twist is, what if I write over here only king? Will it work? Let's check. Oh, so here the code doesn't work as we are now worked. So here I did like this. E is king now, and but it worked with the constructor of A, which is this def init and printf like this. So what if I have my personal constructor? The king has his personal constructor. So let me define it. Def init. I want to many videos. As you can see, it works. So what if I want to call a constructor of emperor also? For that, I'll do this. A simple method which is super. When I say super dot, you can inherit everything. If I say I'm going to say init here, and now let's check what has happened. Oh, I can see. Let me just write over here. Print king. Then comes king only. Why? Because here I'm not writing emperor. Now I have inherited this, and now I can, oh, yeah, now it's fine. Emperor king. So first it works with this. Comes here. So let me show the working. This is the working of the computer. Like it first goes here, then it sees that super init. You can see, and then it goes over here to see the init. Then it prints the init and then prints this. So that's the working of this init. So what if I don't have this? And let me say that the king is useless again. It has not inherited something. And now I'm using class prince. The prince is back and he's inheriting everything from the emperor and king here like this. And here you know what I'm gonna do. I'm gonna define init also over here, then super. Oh, I think the battery is low. I think I should charge it. Please wait. Done. Let's continue. Then, as you know what I'm going to do, init brackets. Done. And now print, or I can say prints. Okay. Oh, let me make an object over here like this. Then I can say p is equal to prints. Oh, I said price. Prints. Now it's fine. Now it's not good. It came emperor and prince. Hold on. What? But I also need also, right? That's truly unfair, right? And that's where we use MRO, which is Method Resolution Order. So here you see that I can explain it to you on paint. Paint is very important. Here you can see A, then B, and then comes C. Okay, so you can see I've written here A, B. First is A, then is B, left, right, and everything works from left to right. That's MRO, Method Resolution Order. Left to right, everything is left to right. Okay, some things are right to left, but mainly things are left to right only. In road traffic jams, and we first see left, then right, then left again. But as you see, left comes first, then right. So first it will take A, and we'll prefer A only till I, let's go back to Python. Yes, here. Till I so here I'm just checking definite self, and I can also define the init of this king also. I can say friend, then what does he have? Yes, he has king. Now let's try and check out. Oh, I think he has already this. So I've run the code and you can see it has come. Cannot create a consistent method resolution order MRO for basis emperor king. That's MRO. We can't do this. So king will be left behind and it will work like this. So that's it for this video. I hope you enjoyed the video. Let me in the comment section if how the series is going, and press the like button also, and subscribe to the channel too. That's important because we are teaching coding here free. So bye bye.